Hello, Algebra. Here we go. 12-4. We're going to work on exactly what we were working on yesterday, except we are now working with multiplying and dividing, which, to be honest, isn't a whole lot different, is it? So when we look at this and we see multiplying, I mean, it's really the same as if we had these all together in one. You just would have to have parentheses around those two. Okay, so the concepts of how to simplify it are no different. So let's first look at this. I do see something right away that we can simplify. 2 and 4. We can divide them each by 2, and we get that. Now the question becomes, I cannot remember because of the subtraction. Remember, we have to look, and there's a subtraction here, and there's subtraction here. So I can't pull out parts. I can't say, okay, I want to cross this C and this C out. They go together. Either I cross off the whole C minus 1 or nothing. Either I cross off this whole thing or nothing. But first we can look and see if we can break it down a little bit. And we can, because there's a greatest common factor of 3. So if I divide 3 out of all of them, I get this. Once we do that and we turn the tables here to multiplication in between these two, I can cancel the 3 or I can cancel the C minus 1. And now you can see that the C minus 1 is what's going to go, the whole thing. So what is left here? We got a 1 up here. 1 times 2 is 2. And 1 over 3, 2/3. That's it. Variables are gone. All right. The next one, oh, lots of them. So keep track of what you're doing here. There's so many things that can be reduced here. So I first will start with the numbers. I see the 5 and the 10. Remember, I can't go this way. You can only cancel something on the top with something on the bottom. When you're multiplying or when you're dividing, you first have to flip it, and we'll get to that in a minute. So 10 over 5 reduces to 1 over 2. 8/16 reduces to 1 to 2. Oh, what else, guys? Yeah, even the 2's cancel. Okay, so those are just gone. And that would have worked if we would have multiplied too, because 8 times 10 is 80, and guess what 5 times 16 is? 80. So those cancel. So we just have the variables to look at. So what I want to do is go across here, and I want to put them together first so we can see how many we have. So when we multiply, remember you add the exponents. So I have only that x, so I'll put that on top. And I've got 2 y's here, so I'm going to add the exponents, so we get y to the 5th. And then we've got the z squared. Let's do the same in the bottom, just to get things together. Okay, we got a y to the 1, don't forget it's a 1. Y to the 3rd is y to the 4th. I'm just going to put it right underneath it, because it doesn't matter the order since they're multiplied. And z to the 2nd. That makes it a little easier for you to see what's going, because it's very clear right now that z to the 2nds are gone because they're exactly the same, and there are no other x to the 2nd, any other x's, so that's just going to stay. Now what about the y's? That's right, we got one more y on top, don't we? 5 minus 4 is 1, so there, y to the 1 or just y. If I were you, I'd pause the video and give C a try. I'm just going to keep moving on here. All right, so I'm checking to see if anything reduces here. No, I cannot go sideways. 6 with these, nope. 3 with these, nope. None of the numbers are going to cancel for me on this one. Okay, how about the r's? Any of the r? No, I can't cancel sideways. No, nothing's canceling at all. So to simplify it, I just have to multiply it. So 6 times 3 is 18. R squared times R squared is what? R to the 4th. 5 times 7 is 35. And S to the 3rd times S to the 1st is S to the 4th. And that's it. There's nothing we could do there. But that is still simplified. It is still condensed together. Now we get into these where the adding and subtracting. So you notice there was, I guess, up here a little adding and subtracting. So we have to first break down, and when you see something like this, you can put it over 1 so it can visually help you. And we need to see if this will factor. So what plus what equals -6, and what times what equals 9. I'm going with 3 and 3. Does that work? Yes. 3, 3, 3, 3. Oh, but I need negatives here. It's okay. Negative, 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 negative. It still works here because a negative times a negative is a positive. So we are going to do x minus 3 times x minus 3. I'm just going to write it above it. Got the 2x there, but again, we can't cancel with part of this because this has this subtraction. This either goes together or I need to factor something out of both. And we can factor a 6 out of this. Divide this by 6, divide that by 6, and we're left with this. And now we have multiplication. So I can either factor out or cancel the 6's or the x minus 3. But I can't do part of this. The good news is there are 2 of them up here. Now I can't cross both of them. I can only cross one of them out. How about the 6? Sure enough, there's a 2, and these are multiplied, so I can split those. See, these were subtracted. There's a difference. Divide by 2, divide by 2, and we are left with x minus 3. Looks like there's also still an x. I'm going to put that in front. All over 3. Okay. So what would we get when we multiply that out? X squared minus 3x all over 3. Okay. Down here. These are multiplied, these are multiplied, these are added. So the adding ones we want to see if we can factor. And I do see things I can factor right here. I got a 3 and a 6. First of all, I can take a 3 out. And A, B, and B, I can take a B out. And then if I take a 3B out, hang on one second here. All right, sorry about that. So if you take out a 3B, what do you have left in here? You have an A, and you have a 2, and the B is out there, so that's what you have left. Let's look up here. We have 2 terms. So you can take out a 3 again. If I take out the 3, I'm left with a 1 and a 2. Now I have an A squared and an A, so you take the lowest one out. And then I have 1A left here and none here. Okay. Oh, that's nice, isn't it, class? Remember, anything on the top, now it's all multiplied. It's this times this times this times this times this. And out go the A plus 2's. And let's see here. I'm going to multiply across so things aren't real mixed up here. I got a 3A. Oh, wait, our 3's can cancel first, can't they? Let's get rid of those right away. So I have a A, 2B to the third. So let's write that. 2A, B to the third. You always want to put the number first. And then, let's see, I've got 12, B to the second times B. So that's 12B to the third. Let's see here. Those are gone, aren't they? And 2 over 6, you can divide them each by 2, and you are ended up with a 6 in the bottom and a 1 in the top. And all you have left in the top is an A. Okay, now we're switching gears slightly, but class, it's not that much different, right? Do you remember how we switch when you do fractions and you're dividing? What do you do with the second one? You just flip it. So that's it. Flip it, and then it's the same problem. Okay, so let's do that. 2 over G stays the same, times G squared over G plus 4. Okay, I cannot cross a G with a G because I've got a plus 4 with this one. But this G I can. That's over there by itself. So I'm going to cross one of these G's off with one of these. And now it becomes a 2. I mean a 1. So I've got 2G on the top. And I have G plus 4 on the bottom, and that's all we can do. Cannot do that, right, class? Only if you had a G to the plus 4 could you cross that off. Okay, let's try B. Oh, it's backwards again. Remember what we do? We take a negative 1 out front. Now I'm going to do this as well. So we're multiplying by the flip of that. Okay, and then now we begin. So that's a difference of squares. So it's a negative n plus 1, n minus 1, and n times n minus, wait, what am I doing? Yeah, 4. Thank you. Okay. Let's make sure I did that right. Factored out an n, and we're left with an n inside and the 4. Yeah. Okay, great. Well, see, now this has to stay together, which is great because so does that. So those are gone. What else is there? Oh, yeah, the n's are gone. Those are separate. So it looks like I just have a negative n plus 1 times n minus 4. We are going to multiply these out now. I'll leave that for now. N times n is n squared. N times a negative 4 is a negative 4n. 1 times n is 1n, and minus 4. Combine like terms. And I have n squared minus 3n minus 4. Got that negative out front. And when you have that negative out front, it just switches the sign of all of them. So I've got a negative n squared plus 3n plus 4. Woofda! That was a little bit longer, but just as much fun. Okay, now on to these. St. Agnes, if you're here, you can turn it off now. We have a different schedule, so we aren't quite able to get to the same amount of things. So you should be set for your homework. All right, example 3. Tanya is playing a carnival game. She needs to pick 2 cards out of a deck without looking. The deck has cards with numbers and cards with letters. There are 6 more letter cards than number cards. Okay, you may have to pause that and reread it to yourself again. But when we do probability, you always remember take the probability of one thing times the probability of another thing. That's ultimately what we're doing. So we got to figure out these probabilities. But first, we kind of have to get things in terms of variables. So all we know is that there's letters and there's numbers. And when I add those together, I'll have my total. Because I need my totals on the bottom of my probabilities. So how many letters are there? Well, there's 6 more letters than numbers. So how could which one could we label X? Yeah, let's label the numbers X, because then what would the letters be if it's 6 more than that? It'd be X plus 6, wouldn't it? So when I add these two to get my total, what do I have? X plus X is 2X plus 6. That's my total. Okay, so that's the number that is in the bag. Now they're going to pick a what? What's the probability that Tanya will pick 2 number cards? Okay, what did we say a number was? X. So the first probability here is X out of the total. Okay, that's one probability. But now, let's see, did they, yeah, so they're not putting the card back in. So things change, don't they? So now, if they pulled out a number here, I can't put X here anymore, can I? Because there's one less number in there now. So how would I write that? X minus 1 over, well, the total isn't the same either, is it? There's one less in the bag in general. So now instead of that, I got 2X plus 5. So there you go. And that is what we have to figure out. See if any of this reduces. So we have X over, can factor out a 2 here. I don't see anything that actually reduces in this one. So we'll just put it all together. X, and instead of the little dot though, I'm going to use parentheses. 2 times x plus 3. And again, this has to stay together, so I'm putting that in parentheses. And wow, how's that for a problem? You may need to rewatch that one. All right, so now we're going to use that, though. So now we got this formula, and it says, okay, what's the probability then that Tanya picks 2 number cards if there are 25 number cards in the deck? Round to the nearest hundredth. So if there's 25 numbers, what did they just give you? Boom, they just gave you the x. So all we have to do is plug in 25 here for x, and we'll have our answer. So 25 times 25 minus 1, 2 times 25 plus 3, 2 times 25 plus 5. So it's 25 times 24 all over 2 times 28. I'm doing all the parentheses if you haven't figured that out. 50 plus 5, 55. And now I will grab the calculator. 600 over 3,080, and it says nearest hundredth, so let's divide that out. 600 divided by 3080. That's what I got. So what would the answer be? All right, so hopefully that helps, but feel free to rewatch these if you still didn't quite understand it, or pause them or whatever. All right, take care. God bless.